Well, hi, good morning, and thank you for joining me here in my shop. Today is January 23rd, and hey, it's not so cold outside. It's just a little bit below freezing now, so. Okay, so the last video ended with me pulling out a disconnected wire and just about kind of recoiling from this radio. This is a strange thing. Very strange. Among the strangest things I've ever found in a radio. Now let's just take a peek at the wire itself. Make sure I'm not crazy. Here it is. There's the unsoldered end of it. Right there. So this wire was tucked kind of out of sight. Maybe up this way, maybe up that way. It's not very long. Can't go very far. Of course, the radio's not on while I'm doing this. The thing is, this wire, and I should not really be tugging on it at all, this wire definitely is one of, just making absolutely sure that I'm not wrong about this. Yeah, there's no question. It's one of the IF lead wires, IF transformer lead wires. So this radio's been essentially working the whole time I've been working on it, except for a burned out resistor, which I found quite a while ago. When I replaced the burned out resistor, whole radio working again. Actually sounding fairly good. I have to ask myself, how could any of that possibly be true with one lead wire from an IF can disconnected? It's either the primary side or the secondary side. It's hard to see how any signal could get through the radio, let alone a strong signal. I didn't turn the volume up very much at all. You know, if the radio was extremely quiet and we haven't found any reason for it, well, this disconnected wire would be a great reason for it. I could still see some signal leaking through the IF transformer, even with maybe the secondary wire disconnected. If the primary wire is disconnected, if that's what this is, then there's no B plus going to a tube, just off the top of my head, because the B plus is run through the IF transformer. So disconnect the wire, disconnect the B plus, stop the tube, stop the radio completely. So I don't see how it could be a primary. If it's a secondary, and which can are we talking about? We're talking about the first. Wait a minute here. What are we talking about? Yeah, we're talking about the second can, the one back here, the second can. Yeah, I've got no real explanation. Let's take it. How can we figure this out? How can we figure out what is what? Well, that wire is connected to a terminal that has other lead wires on it. Capacitor here, and there's a bare wire going. Looks like it's going to this terminal here. This ground is grounded. Oh, this is a grounded. Oh. Is that what this is? This is a grounded. Yeah, for sure. I tell you, man, I can't keep my thinking straight. Even as I'm doing this, I start thinking the wrong thing. Because the wire comes by this terminal, I'm thinking, oh, it's on this terminal. No. The wire goes all the way up into the IF. So maybe if I ohm it out, well, there should be 4 wires coming back. Okay, so let's see if we can spot them here. I need more light. Give me more light. How about this blaster of light here? Yeah, okay. So this one goes down. That's 2. This orange one this orange one goes down, comes to here. There's a red wire. This is probably B+. So that's 3 wires I've seen, right? 1, 2, 3, and 4 is this. Oh, right, this one. The one I worked on. That's because I'd reached the conclusion that a pi filter is also tucked up inside here. And this is coming out beyond the pi filter. The RF pi filter. So some other strange behaviors in this radio that maybe we can ponder a bit about. Let me just turn this light down a bit here. AVC voltage remains fairly steady around a volt, minus a volt. It doesn't seem to move up and down. If I interrupt the audio feed coming from the detector, the defector, defector, coming from the detector, if I open that up, so there should be no audio then traveling to the speaker, we can still hear the radio playing somehow. That, I believe, is a function of the detector tube itself, and that I'm suspicious now that all these radios leak a bit of audio if they use a tube that contains both the detector diodes and the triode amplifier. Because I believe they share a cathode. And I'm guessing if the cathode is at all restricted or worn out, the electron pool will start to rock. Okay? What? I gotta rock. What other weird? Is there some other weird behavior in here? So it can't be the primary, or for sure I don't think. For sure I don't think. I don't know what to think anymore. But I with what's in my brain, no B+ to a tube because of this open wire, no radio operation at all. So I could assume it's a secondary. That would be the other wire. That would be the brother of this wire. So the let's look at the schematic. I'm at a loss here. To the schematic. So what we're talking about is here, and we're talking about these 4 wires. One goes straight. So I could begin identifying these wires one by one that are coming out of the can, and then we'd find out what wire it is that's hanging out. I think it's this. How can that be? I mean, if this is not connected, how? Maybe it's this one. No, it's coming out of the can. Coming out of the can. And my belief now is these components are inside the can. That doesn't make a lot of sense to me. That's not how this would normally be done. These are usually sitting outside. Easily found. But I didn't find them. Part of the mystery. And in case we think Model 52 is any different, I think it's exactly the same arrangement here. Looks like something a little different happening here. Not that it matters, because this is the radio here. Yeah, not really. I think they drew it slightly different here. Okay. We're getting nowhere. Nothing happening, getting nowhere. Process of elimination to determine what wire is there, I think, is a better way to go. So trace each wire to its terminal point, see what it is, and then I'll know what the wire is. Okay, that's what I'm going to do. So, because I've been looking at things very closely, I've of course spotted another weird thing, which may be nothing, maybe something, but I want to take a look at it. It's a capacitor up here, up in behind here. You can see the top of, it's one of those mica square capacitors. You can see the yellow dot on it. Behind this coil, where you can't see right now, the lead, the bare lead, comes around and reaches a terminal on this tube, but on the way it brushes a ground terminal, and it certainly looks like an accident. So I want to take a close look at this. We're going to switch to the other camera. Just a little out of focus there. So you can see the wire from the capacitor kind of going past that terminal that's sticking out. And, you know, yeah, try as I may. Okay, let me just change the focus a wee bit here, and maybe I can get it in a better view. You know, I could just reach in there and bend the wire away and be done with it, but I want to know if this is an existing thing in here. What is it doing? Oh, it looks even weirder now. It really looks like it's been bent behind the So that's a ground terminal that's available for use in the radio, but they haven't used it. And that terminal is actually part of the socket. Well, I guess all the terminals are part of the socket. But you can see you can see how it's done there. It's actually not connected into the tube pins. Now that wire rises up past that ground and reaches this terminal. That's right in front here. So there's a black wire. Yeah, it goes to a 22K resistor. That black wire comes to this terminal. This terminal follows a red wire. You'll have trouble seeing it under the white capacitor. You can kind of see it. Comes up to this terminal. This terminal connects, this is the end terminal here. This terminal connects to this yellow goldy wire. The goldy wire is one of the wires going down into the IF can, from which there is a disconnected wire. This other green one here, you can't quite see the end of it. There. So, is this terminal accidentally grounded? Oh my gosh, could that really be the case? So I'm going to get the ohm meter and stick it on this terminal and see if the terminal is grounded by that. What really looks like that capacitor is in contact. Oh my gosh. You know, like if somebody brings you a radio and the radio does not work, then you expect to find all kinds of nonsense. Or, well, you don't even expect to find all kinds of nonsense. You might not be surprised if you found a bit of nonsense in the radio. You might say, oh, that's why it's not working. Nonsense. But when you have a radio that's working fairly well, it just, you know, the chances are the nonsense is just in your head. Certainly in my case. Okay, is this thing grounded? Now, it may be grounded by virtue of the fact that we saw that connection. It's right here. Oh, that was not a good test. Not a good test. Let me get on a good spot here. Okay, I think that's a good spot. Okay, it's this terminal. It's not grounded. Oh, what was that? What was that went by? Okay. Try again. Is that a capacitor charging? Well, certainly isn't shorted the ground. So that's 130, jumping around, way down, 120,000 ohms. And I'm on the other side of this resistor, which we can look at on the schematic. 22K, first encountered from the red wire, from the orange wire, from the IF can. So this is the wire I think I'm dealing with, and this is the resistor I think we're looking at right here. And what about it? I was checking to see if one end is grounded, and I'm wondering if there's a capacitor. This would be which end am I testing here? I was testing wait a minute, something not quite right here. That's right on a tube terminal. So we have, oh yeah, there we go, 22K, right on the tube terminal. So I'm testing around here. I should test the value of these resistors. Maybe one of these is open or something like that. That's happened. And again, this little package here appears to be inside the can, which is hard to believe. It's not impossible, but it's very hard to believe. The reason is they make these cans kind of standard, and they're going to work in a number of different radios, and they may not want to incorporate, or this circuit may be different from radio to radio, depending upon, you know, the tube that's used and everything else. So they probably wouldn't want to incorporate this inside a can. But I'm just guessing. Guesses aren't worth very much. So what if this guy was shorted? Well, I don't know. What if he is kind of shorted by this guy? Let's check these resistances, because I'm really kind of confused about what I'm trying to do here. I'm trying to find out where this supposed hanging out wire is. You know, the way they've shown this, it would appear that this wire and this wire are coming out of the can separately. Like, properly drafted, this line should go here. And then that would kind of suggest it's outside of the can. There'd be a single wire coming out. But the way they've shown it's not like that. And it's just a drafting thing, and mostly a draftsman's concerned about filling the white space nicely on the page. That's his concern. So he could have drawn it this way for convenience. But this further suggests this is actually inside the can, and this is the wire coming out. And this is the wire that's going nowhere. But look where it's supposed to go. The way the wire was laying, it was nowhere near this connection. And of course, this is up on the top of the radio, and there's a wire coming back, I guess, to a terminal. Well, if this isn't connected, how can you hear anything coming out of this radio? Now, how would the volume control work? It wouldn't work. This is crazy thoughts here. Just, yes, time for a break, a little bit of coffee, and maybe a renewed approach to this. I'll show you my fancy diagram I've drawn. I had drawn a diagram here. Here it is here. The two tubes, the connections, I figured out the pin number and therefore what the component is. So coming out of here, one wire is going to the plate of the 7B7 and the other wire is going to the two diodes. It all makes sense. It's perfectly right. This would be the secondary side, getting to the diodes to be rectified. And this looks to me like it should be the B plus feed for the plate over here. I don't know. I don't know completely. Go drink coffee, Jim, and clear your head a bit. Who said that? Okay, we look at this now. Look at this. These components are numbered 35D, 35E, 35C, and look at this, 35, 35A, 35B. So what so these are definitely inside this can. And then out is coming this wire, which is disconnected. Now, was it disconnected? Did I tug it enough to disconnect it? My experience when I came across this wire, which unfortunately is not on video, I was just tugging it a bit to see where it was going. You know, you shake the wire here and look at the other end and see, you know, kind of trace along. And when I shook it, it was obvious it was not connected. There was no sensation that I yanked it off of something. It seemed absolutely disconnected. How could that possibly be? So we need to, well, we can't find these. We know they're inside the can now. Get my head straight here. This appears to be the wire that's disconnected. So what is connected to here? This is just gonna drive me nuts. Because I have the green wire connected. I have another green wire not connected. So wait a minute. So wait a minute. So I have the diode wire. I have the plate wire. Let's, you know what? I've got to do something better here. Got to do something better. Okay, let's see if this can work out here. I don't know. Wait a minute, I can't hold that up in the air. I can do this though. Okay. There's my fancy diagram. Now, let me just do this. And that again. Okay. So, I have traced these two wires. This one is the green one coming from the two diodes in the 7C6. That's here, that's these two. I don't know, get everything on screen at once? Maybe not. That's these two. This is the green wire. Instead of going straight here where it used to go, it now goes up, out to the earphone jack, meets up with the closed switch, and comes back on this red one, and attaches here. So it's just going to here. So normally if there's nothing plugged in, the green wire is hooked up here, just as it always was connected solidly here before. That green wire is connected to this 22K resistor coming from the two diodes, which it all proves it absolutely. This is the, unless somebody mixed the wire. No, this wire was factory connected to here for sure. Okay, next wire to deal with. So coming up is this yellow one. The yellow one passes this terminal and goes to this terminal. Now, did I get that right? Because it's very confusing. It looks like this wire looks like it just continues right along, but in fact this wire stops at this terminal. This is the wire that continues right along. It's very hard to see that. I have to get up really close. And I'm going to verify it. If it's hard to see, I could have made a mistake there. Would that matter? Okay, get down like this. It's quite clear. That's exactly what's going on. From the angle we're looking at, it looks like something different. But if you look at it up this way, it's quite clear. This yellow wire is coming over to this terminal here. So what? So this terminal is terminal number 2. Terminal number 2 on the 7B7. If we look at my diagram, 7B7, terminal number 2. My book tells me 2 is the plate. So we have a plate connection on the 7B7. The 7B7 is the IF amplifier. So this is the output of the IF amplifier heading up to the primary of the IF transformer. Now, where does it go from there? From there, the primary side, pretty certain to come over here, pick up on this red wire, and this is the B plus supply coming. Now how do I know that for sure? Because I followed this wire all the way along in the radio. And this is the terminal. This is the wire coming to it from the IF. And this has a red wire connected to it, and the red wire comes around to this terminal, this terminal. This terminal, it meets up with this 22K resistor, and it also meets up with another resistor. This is a mystery. This resistor looks like green, could maybe brown, maybe red. Green, red. So, green is 5, 5100. There's no such resistor in the set. Okay, this is an issue I never settled, so let's settle it now. Let's try to settle it now. I'm going to read the resistance of this guy here. Which guy was I going to read? Let's check a bunch of these. This is supposed to be 2.2 megohms. 2.2 megohms. I think I checked this one earlier. 2.5. That's not going to cause a problem. That's not the it was this one up here that I wanted to read. So it's 5.6 K. 5 green. I don't know what color that is. It looks brown to me though. So something around 5,000 ohms. Okay, looking at the schematic for 5,000 ohms. So we think, where's my pointer go? Here it is. So I think I am coming down this wire. I found the 22K, and then there's another resistor of around 5,000 ohms. There's a 1,000, and then there's a 22,000 that way. This wire goes all over the place. 220,000 that way. Nothing up this way. But it is B plus we're dealing with here, the distribution of the B plus. And there's a red wire. Oh, I find this very confusing indeed. So the other end of this hooks up to a capacitor and another resistor. Can we see that if I follow the other end of this? And right on a terminal. I didn't ever follow it this way, but there's no other resistors that way, just here. So what I see in the radio is I see a 22K, and then I also see the mystery, the 5,000 ohm resistor. Is there a 5,000 ohm resistor anywhere in here? These are all mixed up, I think. Yeah, not very attractive to do this. 5,000 ohms. So I look for the word ohms out here. There's the 1,000. 220. It's worth finding this one and checking it. It's probably the a cathode resistor. 33. No 5,000 ohms yet. Megohms. Where was that? And these are specialty pieces. So we appear to have a resistor with the value 5,000 something in it, and no sign of such a resistor on the schematic or in the parts list. Silence. Yes, silence. Silence. Okay, I'm going to stop for a bit and just consider the situation here, because quite a number of things are not adding up properly. I find that very paralyzing. Didn't even have to drink any coffee, and I thought of something. I should try operating the radio. If that wire was just barely tacked on somewhere and it was functioning the way it was intended, and then I just touched it and off it came, if that's what happened, then the radio probably doesn't work now. On the other hand, if the wire hanging out here, if the radio works with the wire hanging out here, what do I do with my pliers? Then that would suggest there's an alternate wiring going on in here. Goodness knows how that would happen. Okay, I really don't want to tug around this wire too much. Because it goes right up into the IF can, to a terminal up there. You don't know what's going on up there. I don't want to find out. So there's a hair or something on here. I keep thinking it's a wire. It's this piece of thread from the insulation. Okay, so this wire is now hanging totally free in the radio. Can this radio work? So we need to unplug this, make sure the switch is closed. Oh my gosh, I can't believe it. Here we go. Volume is down, switch is on, power is on. Okay, take a moment here. There's not much to straighten up. Try. I don't have an antenna hooked up. Don't make conclusions without the antenna connected. A lot of these radios are very, very quiet when there's no antenna connected. Holy smokes! When they built this radio, they didn't need a part, and they put it in, and later somebody's cut the wire to the part, and the radio still works. No, this is not possible. This is not... Where's my coffee? Where's that coffee?
And if you're Kyle Lowry and you want an opportunity?
Well, okay, so what if there's not just 4 wires coming out of this cam? What if there's a 5th one? I haven't seen it. And what would the 5th one be? 5th one might be this. Ground wire Now you would think if they're going to put all this in the can, then they would connect this to ground. But what ground? What ground terminal do they have in here? They might not have anything. So they bring a wire out. The fifth wire comes out to go to ground. Now what if you don't ground this? Well, you would defeat the filter here. The filter wouldn't filter. And what would the implications of that be? Probably not much. Probably not much. So that's what this could be. This could be, the wire sticking out there, going nowhere, could be this. I need to count carefully the number of wires coming out of this can and see if it's 4 or 5. Okay, let's do that. First, I better turn this off.
Feels more like
How many wires come out of the can? Clearly, I'm going to have to use the close-up camera for this. I'll get my 3, 4, 5 box. Handy thing. So we are trying to study what is coming out of the hole right in here. Okay, let's switch camera. You have to bear with me while I get this happening, because there's liable to be a focus issue. Let's see. We're trying to look right down on the edge of that hole. There's a ground terminal right here. You'd think if they had to bring a wire up and ground it, they would ground it right here. They wouldn't run it. See, there's the very end of it right there. Oh, you can't see what I'm doing. Jim, I'm using the mouse to point at stuff. And you're not, yeah, okay. So anyway, let's go back to this. So here's the very end of the wire right here. So that's one. Then I see a green one here. This is the one that carries the audio out. 2. Now, as you can see, just a touch of orange down there. That's this wire here. Not that one. This one. See it move there? Did you see it move? Yeah. So that's, how many have we counted now? And I forgot how many we counted, so let's just keep going on. This is number I don't know what now. This one goes down into the can. So we'll call this 1, 2, 3 on the orange. This green one looks like it goes to this terminal. I don't think it goes anywhere else. Sure, it looks like it just goes to this terminal here. Yeah, I don't think that's going down into the... So from here, we can see again, the orange one coming out, green one coming, that's the wire to nowhere, that's 2. You can see in the top corner here, an orange one, you just barely see it, let me get my finger out of the way there, orange one. Oh, wait a minute. Yeah, and that's this one here. This one. You can see clearly now from this view that it goes past this terminal. From the other view, it looks like it ends at this terminal, and the other orange wire is the one that continues by, but you can see clearly it's not the case. It comes over to this terminal here. I'm still counting only 4. I've only got the 4. What can we see right up inside that thing? So I'm going to get more light. I'm going to get more light. Gotta get some more light. Can we see right up inside? So you can see the bottom of the coil form. on a bracket going across. Just to let you know what I'm looking at, if I can point in here. Hard to point. So that wire that's moving is the disconnected wire. There's no question it goes down in there. Oh, wait a minute. Is there something else there? No. It's very helpful when you use two eyeballs in stereo vision. Using mono vision like this is very tricky stuff. Come on, give me a fifth wire anywhere. Okay, another alternative. So this is the wire. Yeah, that's stupid again. I keep having this stupid thought. I keep thinking the disconnected wire is hooked up to this terminal here. I just keep rolling over the same false thought. So now, not using the camera, just looking with my own eyes here. Is there anything else I can see? I see 1, I see 2, I see 3, I see 4. Where's number 5? I don't see a 5. No 5 coming up. Oh my gosh. So, pretty clearly only... Hey, what about a wire coming out the top? Is there a wire coming out the top? No, there's the wire coming out the top. It happens, but I don't think there's any wires. There's a wire coming out the side. A wire out the side. The wire out the side. Yes, the volume control wire comes out of the side of this. Oh, have I ever got things messed up? Hey, nothing like a little extra excitement here. Okay, there's the fifth wire. So that's the fifth wire. So that means my theory that the wire that's not connected is actually a grounding wire is probably valid. And there's a chance that wire was touching the chassis, although it's not now. Okay, so how would we prove before, like I'd like to ground the wire now and see what happens. But I mean, what could happen is it burn the coil out, ruin the radio. Don't want to do that. Got to find out what's going on this wire. So conceivably now, it's the wire it's the grounding wire from between the two capacitors. How would I become aware that that's what this is? Pretty much by grounding it and seeing what happens to the radio's operation. But it's grounding away RF. You can't hear that. Why do they even bother doing it? Well, because they don't want it feeding back through the radio. They want to get rid of that, especially in the case of the AVC. But they've picked the AVC off, the AVC DC voltage off another spot. Probably this filter can still, I don't know. Well, they wouldn't put a filter there if it wasn't needed. And they wouldn't put a ground wire on it if it wasn't needed. The other thing is, this wire is only so long. Is it long enough to reach a grounded terminal conveniently? It is grounded. Oh! No. There it is again. Once again, I've made that same mistake. I keep looking at this wire, and I forget it's going up to the coil. I start thinking it's on this terminal. Boy, I tell you, sometimes it's just a reoccurrent, incorrect thought keeps coming up. Jeepers creepers. And it has to do just with the visual presentation. Okay, so where can this wire go? So it was tucked up under here. So it'd be heading to one of these terminals. Can't be this one. This one's too far away. Could be this one. Could be this one. Are one of these two terminals grounded? Right, that's the right question. That is the right question. Are one of those two terminals actually ground terminals? Is one of them right on the looking to see how the. Let's use the meter. Get a more. The meter can mislead you, and the visual can mislead you. Mislead me. I don't know about you. Mislead me. Okay, we want to find out, is this a grounded terminal? We would say no to that. Is this a grounded terminal? We would say no to that. Well, let's keep going. So what about this one? Getting a lot of weird. There's a 0 there. That was kind of strange. Let's try it again here. So that's what's it doing there? It's telling me it's both open and when you use both leads holding them on, then either one of them can interfere, and it can become very difficult telling which voltmeter lead is not doing its job. So first, grounding, yeah. Back on here again. We'll do them all again. Definitely not grounded. Definitely not grounded. Definitely grounded. So can this wire get all the way up to there? Wow, I don't think so. Why is that terminal grounded? Because that's the support terminal and it's riveted. Yes. So there's no question that's grounded. That wire make it to that ground? Let's just get a hold of it here. Put that up underneath. Not really. No. So there's another grounded terminal right here. Like, why wouldn't this wire just loop around and come back to the ground here? I can see no reason why it shouldn't be connected that way. So maybe it was. Maybe it was, and somehow it got stretched out, and then somehow it got lost, overlooked, and somehow the radio kept working because it's not a noticeable problem. Other possibilities. One of those capacitors is shorted, and by lifting the ground, it brought the radio back to life. How about that possibility? So if one of them was shorted, it would be shorted back to what? Shorted back to the let's just read the resistance on it and not think before getting some data here. Just put this away, didn't I? So resistance to ground of the mystery wire. Small capacitors. I think if I put my meter on a high setting, I think we might be able to tell that it's a capacitor on the end too. So we're going to grab this wire. Grab this wire here. Okay, so it shows just open, open, open. Open, open, open. Well, they're small capacitors, so they might not show up kind of on the meter. Hey, the capacitors are on either side of the resistor. One side of the resistor is coming out on the wire going to the volume control. So if that's the case, I don't know what happened, man. My coffee just quit right there. Coffee was fueling me, and then I gotta think about this just a little more. Very close now. We're close to figuring this out.
So now the theory is this is the wire that's not connected. And what I could do is I could get on the end of this wire and get on the wire that goes to the volume control and measure the capacitance between here and here. See what happens. Measure even the resistance from here to here. We should really see if the resistance from here to here should be, super high, because you're going through these capacitors. You can't read the resistance through the capacitors with. Well, okay. So I got to get on the input side of, or where this wire is from the side of the cam. Boy, did I ever. 5 wires. Oh, wow. Just couldn't put the thoughts together till just now. So anyway. We'll go from here and read the capacitance from here to the wire. Let's see what we get. Well, I just put that multi-super meter on it and see what it says. The multi-super meter. That would be this guy here. So we want to go on the wire that's on the volume control and just come out of the side of the can. And that one is... absolutely sure. That one is that one. That's what I thought. Okay. Okay, so that's one end. Now we'll try to get this on the other end here. The wire. See what this guy says. What's he say? He might just say, I'm all confused. What have you done to me? So this says a capacitance of 200 picofarads. And 200 picofarads is, well, it's kind of magically correct. Let's just look at the schematic again. Because 200, there's 100 and 100. I get maybe, I don't know, maybe the resistor kind of does nothing. Does it appear like nothing during that test? I don't know. But anyway, we certainly didn't find a resistance reading here, and we didn't, from here to here, we didn't find any indication that there's a problem. Let me put the ohmmeter, regular ohmmeter on there and see what we get. The regular ohmmeter. Okay, I'm just going to click this to ground, make sure. Okay, take this off. Wire. So I'm on the 60 million ohm setting on my meter, and it says this is open. Now what if I reverse these briefly? I'd like to see the meter kind of show the charging up of the capacitors. That's what I'm getting at. But they're small capacitors. Here we go. Watching the meter now for a jump. No jump. But we did read the proper capacitance using the other instrument. I don't know for sure that this was going to jump with 100 picofarads. Next thing, we got to try grounding that terminal. Find out what happens, because what else could we do? What else could we do? Yeah, we could hook up an oscilloscope to it and look for some kind of RF there. Why would that help? I don't know. It sounds like fun, though. I hadn't had my scope going for a long time. Okay, I've connected my oscilloscope. You can see back here. Connected it to the wire. Just grounded the lead to the chassis. And we're going to give this a go. Got my scope set to 1 volt per division. We'll see what we get. What do you expect to get before you hit the switch? I would expect to see a bunch of RF modulated by the voice that we're hearing if I set the speed of the scope just right. That's what I think.
Okay, here we go. And watching this, I'm going to put this on DC in case there's a DC voltage. There should be a DC voltage. Should be negative. Should go down. On here. Volume up, please.
A little bit more on your plate. So it's interesting to me from Zach Taylor, but also that Brian Callahan's father was a head coach in the NFL and has been lauded as one of the best offensive line gurus the game has ever seen. Be very interesting to see if he makes a call. Hey, Dad, are you busy? I need an offensive line coach here in Tennessee. We'll keep our eye on that. Brendan D from The Score and the Double Doink podcast joins me now. How are you, buddy? Oh, we got him? Just having an issue here. There he is. There he is. How are you, pal?
I'm doing, man. How you doing?
I would say living the dream, but I'm not because, we kind of discussed this yesterday over text. I was not okay, but I am feeling better today because next year is another year and woohoo! But we'll get to that maybe in a little bit. Before I get to the Brian Johnson stuff, I wanted to talk to you about Brian Callahan because we're bringing in the cap for a period of 2 months.
All right, so Immigration Minister Mark Miller announcing the other day that cap on international students, it was hitting about 900,000 people a year, largely coming to major municipalities, obviously in Toronto, talking about a lot of the issues surrounding Toronto.
Okay, just quietly watching the screen here. So the first thing I noticed is that this is not a balanced display. There's more stuff down below than there is above. And I wonder if that's just the diodes cutting off the top and what's really left is the bottom. The other thing that's really obvious is this is painted with RF in here. That's why we're seeing this bar. So this is RF at the pi filter ground point when it's not grounded. So we should really look another place for this, and that would be top of the volume control, grid of the triode on this tube, and see if the RF has made it all the way to there. Yeah, I think that's what we should do. So I'm going to move the scope from where it is now to grid of the triode. Grid of the triode. I think that's going to take me a moment to figure out here. Okay, I still have the radio going here. I haven't done anything. I'm going to move the lead from here to the grid of the triode. This wire's going to fly around. Good. Interesting. Change the volume of the radio. The volume went up. Okay, now we'll look at the grid of the triode. I believe it's right here.
And they're really losing out not only on money on the table, but for longer term rent.
Oh.
International students need.
Sure, the grid of the triode is controlled by the volume control.
What do you think is motivating the decision by
a large amount of RF in it.
these units to being short-term rentals? I mean, presumably they wouldn't be doing
Okay.
it if there was no market for
I know the next experiment now. The next experiment will be to ground that wire. I'm really very sure now. But again, my sense of sureness doesn't mean anything. I'm going to ground it with a
decade box here.
So I can... Oh, this doesn't have a 0.
Hey, they don't have a 0 on here.
Well, we'll bring it down as low as we can. We can come down to as low as 15 ohms from a start of 6,800 ohms. Okay, so I'm going to grab that wire. And it's going to ground. So we'll ground to ground. Now we'll listen to this.
On houses in favor of a number of companies who purchase houses to convert them to short-term rentals. So houses, typically in older neighborhoods, are now
No surprise that the volume goes down a little bit. The real question is, what about this RF? We just want to see a nice. So I'm going to decrease that resistance now. So we're going from basically 7,000 down to 2,000.
No change.
Okay, we're going down to 1,000. No change. Going down to 500.
Back and forth, back and forth. I don't really see any change there. A little more volume.
Okay, that was going to be my question about who are the occupants of these facilities? Is it tourists? Is it people who are just in town for 2 days?
Okay,
You mentioned,
down to 200
how long is
ohms,
for visits that a
100 ohms,
It depends on who they work for.
50 ohms,
It could be from 6 weeks
33
to maybe a
ohms,
month or two. I know Airbnb has rules.
15
you can't
ohms.
stay longer than 30 days, but
Now, I'm going to disconnect this,
short-term rentals, it doesn't necessarily
and we're
have
going
to
to
be
see
short-term rentals.
what happens. Here we go.
That we are a hub for the northern communities to whether they're scoping out schools for their kids, attending medical.
put it back on. This is
Those longer-term
10,000 ohms going to 15 ohms. This is 10,000,
people coming to do business in Thunder Bay.
15.
And Councillor, is there a situation here
10,000,
where we have
15.
not enough sort of hotel investment, not enough
No
units
difference.
constructed, or are those empty in place of this? And are there just a general need for more rental units?
No difference.
There's, the interest in building them, but it's not happening right now for whatever reasons.
15 ohms.
We are building hotels as fast as we can. I think we've had 2
Okay,
hotels, which doesn't sound like a lot compared
From
to
here,
town.
our only option is to actually ground it right out.
We are
like
putting
really
hotels
short of the
here.
ground.
As the last I checked,
Okay, so
we're
we're
at
going to do
83%
that.
occupancy, which is extremely high. It's quite difficult to get a hotel in Thunder Bay. And the hotels
Take this off.
are doing very well. So if you are looking to invest into hotels in Thunder Bay, please give me a call. We have some opportunity there for sure.
It's interesting, when I connected something up, the volume went down, but when I changed the resistance of what I connected up and down, it didn't seem to do much. Yet if I disconnected it, the volume went back up. So some kind of capacitive thing going on? I don't know. I mean, this is a pretty sloppy device, right, to hook up to sensitive parts of a radio. The next step, though, is just to ground it. I'm going to use a long wire.
The other piece is that if they are running a commercial in place, to say if somebody buys a house, the
Yeah, we want to keep an eye on the
commercial,
scope when we do this.
for property tax is a 1 ratio. So a hotel would pay 3 times the amount in the same assessed value than a house would. So if a hotel is worth $100,000,
I'm on the wire.
$100,000.
I'm going to ground it. Tapping to make sure. Grounding. Take it off. Put it on. Take it off. Well, it looks to me like it's draining out some of the RF, maybe half of it on the scope. Not all of it, that's for sure. Would we expect it all to go? Another place to go looking for it would be far side of the ABC capacitor. And look for RF on the grids coming back. What? That's a tough one. Another one would be what? Well, RF further in the audio system, so we could look at the grid of the output tube and see if there's RF making it there. I mean, that's probably the critical thing, is you don't want the RF to make it that far. So maybe, it's chopped down through a series of stages until it's not significant when it gets to the... Yeah, so let's do that. So we'll put the scope on the grid of the output tube. The output tube was what was it? Does anybody remember what the output tube was? Okay, just 1 second here. I'm going to take a look at the schematic. The output tube is a 6K6, right, 6K6. So what's the grid on a 6K6? 6 HIJK. 6K6. And the grid is this one. That's number, let me put under some light here. Number 5. Pin number 5 on the outing put tube here. Okay, that's that tube right there, and number 5. Number 5. So okay, get down here to count them. Okay, that was the key. 1, 2, 3, 4, 5. A little hard to get at. 5 has... Get that out of there. 5 has... What? 5 has nothing connected to it. Come on. What am I doing here? Try again. Let's try again. Key. 1, 2, 3, 4, 5. Wow. I don't think there's anything connected to that pin. Oh, I'm looking at the wrong tube. Wrong tube. That makes more sense now. Okay, 5. Here we go. 1, 2, 3, 4. Pin 5. Okay. This is the grid of the output tube. Make some noise? Nope. So we're on the grid now. Okay, what's going on here? A little more brightness. Very hard to set these things with a camera. Like my eye is seeing this just fine, but you're just kind of seeing a white smudgy thing there, but I'm seeing all the individual lines. So there's no RF there. There's no RF at this point. It's all audio. Still looks unbalanced. Looks like the bottom is rounded off, the top has sharper peaks on it. And you saw when they're quiet, there's a hum in there, causing the split in the... Well, I slow this down a bit. You can see the hum better. In fact, if I tune off, there it is. So I'm going to lift the ground. I'm going to leave the radio tuned between stations. I'm going to lift the ground and see what happens. I'm lifting it now. Well, that's interesting. I'll put it back on. Now, you can see these in the camera. This gigantic peaks here, those are the clicks that we're hearing. They're tremendous. Just tremendous. Now we're going to tune to a station. I'm going to take the ground off the filter.
Alright, let's go to our big trouble traffic spots. And out for a crash in the Bradford area. This is on the southbound 405th line, blocking
I don't know, what do you think?
There's a bit of a delay right through the 5th line ramps.
There's some RF in there.
You can use Council Road 27 instead to go south. Drop into Mr. Luke anytime, any day for expert care, oil changes, through the tire services. Open early, open late, open weekends. Mr. Luke.
The problem with these radio stations is they're never quiet, right? They don't go quiet. Yeah, there is RF, I think. Hard to say. Find somebody else who's broadcasting silence.
Get a quarterback or a rookie deal because let's say Fields does play well. You're going to have to pay him.
There it was. I saw it.
You might have to pay him money now, right? So I really think kind of resetting the offense.
Okay, applying the ground.
I really like Caleb Williams and Drake May too. I think that's another aspect of this. Like I think they're two really
It's definitely less.
good quarterback prospects. It's better quarterback prospects than Justin Fields was. And like I would be shocked if Justin Fields turned out to be a better quarterback than Caleb Williams or Drake May. So that's just kind of how I look at it. I get we can get a haul for Justin Fields, we can get a haul for the number one overall pick, but you still have to make those draft picks, right? You still have to find the guys. Look at what happened with the Cleveland Browns when they traded for the number 2 overall pick, the Eagles, for Carson Wentz. They got nothing out of that deal. But what happened when the Rams traded traded the number 1 overall for
Trying to get a new perspective.
Washington got no one really in that trade.
Well,
Things like draft picks,
I think I'm going to stop here today.
and I think if you're the Bears, you have to pick ready for you don't have to.
It would strike me the thing to do is to ground that wire. It does seem to reduce the RF a little bit. Doesn't eliminate it, does it? What's going on with this? That's what I would say about that. It could be everything from this wire hanging out here. Nope. The fact that I have it plugged into a isolation transformer could cause that. We've got that's my tripod giving out there. We've got in a unpolarized plug. Should I turn it around? Doesn't make any difference at all, of course, but this is the isolation transformer. So I plug this into a grounded outlet. The situation could be different, but I have not made it myself aware of how all that has been handled. And you know, we still have this block capacitor down here too, which I kind of said something about at the very start, and then I really haven't returned to it. The block capacitor is right on the power line, and that's probably not a good thing. Yeah. Think a bit about that. I gotta think about all this stuff before I take any action. I think we're right there, though. I'm pretty sure tomorrow I'll be able to walk away from this radio and say, good job done. I really have not done very much to it. Okay, well, thanks a lot for watching this crazy video, and hope you're getting a kick out of this, and maybe learning a few things along the way. I'm trying to make this interesting and fun for myself. Hopefully I'm doing the same for you. And thanks again for the super thanks. I really appreciate that. It's very encouraging when I see the number of likes, the like ratio, and anything else like a super thanks and stuff like that. It's very, very encouraging to me. I need that encouragement. Okay, I'm done for today. Thanks a lot for watching, and we'll carry on tomorrow.